Hello, ladies and gentlemen. Welcome back. We are now in the third month of 2020, and I have to say, it has been quite an exciting first 2 months. And I don't mean exciting in a good way. I'm talking about anxiety and fear. Many things are happening all at once. But just like a line graph, you have your ups and downs. This coronavirus is a spike in the graph. The disclosure of the massive explosion in space is a spike in the graph. The government repositioning of military is a spike in the graph. And we have seen quite a few of these spikes within just the first 2 months of this year. So we are going to discuss this virus. And what I would like to do is, instead of focusing on all the hype surrounding this topic, I want to actually focus in on the realities of this issue. For example, and this is not hidden information, it is available for the public to see in updated reports. The CDC, Center for Disease Control, reports that as of March 4th, 2020, in the US, there are 80 total cases and 9 deaths. WHO, the World Health Organization, reports that as of March 4th, 2020, in the US there are 108 confirmed cases and 6 deaths. The CDC and the World Health Organization are probably the two main official authorities on global health and things of this matter. And then you have the National Institutes of Health and so on. Actually, the NIH links to Johns Hopkins CSSE report, and that reports as of March 4th, 2020, in the US, 138 confirmed cases with 9 deaths, who in turn source data from the WHO and CDC. Now, I'm no mathematician, but with these organizations being the top organizations, pulling sources from each other, wouldn't you think that there would be some consistency in the numbers? I'm just looking at what they put up. It wasn't hard. Look, a confirmed case is a confirmed case. A death is a death. There should be no discrepancies with those low numbers. But there are, from all 3 sources. Why? How? So we are going to get into this. And we are going to look at some of the issues and info surrounding this, as it is time to start separating the hype and fantasy from the real. So, for starters, let me disillude you from the idea that this virus is going anywhere anytime soon. In fact, it looks like this is going to be spreading among us for a very, very, very long time. This is the first thing we need to accept and understand. Also, the virus that we are dealing with right now is structurally not going to be the same virus that we deal with 6 months from now, a year from now, 1 month from now, even in one host, because of its aggressive replication as an RNA virus. It can't stay the same. With the population's genetic diversity, it has to mutate and make adjustments, especially being an RNA virus. DNA viruses replicate in the nucleus of a cell. RNA viruses replicate in the cytoplasm of a cell outside of the nucleus. Well, let me just do this. A little science here. It's a bit geeky, but I think it is interesting to know some of these things. It will ultimately help you to understand what we are dealing with, thus eliminating a lot of confusion and fear. Besides, viruses are a part of life, everyday life, really. So it would be a good idea to educate yourself on something that is part of every human's life. And if more people did, a lot of these diseases that we have, a lot of these diseases people develop in old age, like Alzheimer's, would not be here. We would have a much healthier population, and new viruses like this wouldn't stand a chance. So let's talk about replication, mutation, and mutation rates. I want to read something to you and explain as we go, and this comes from the PLOS Journal on Pathogens. The not-so-infinite malleability of RNA viruses, viral and cellular determinants of RNA virus mutation rates. And this was published April 2017, authored by Everett Clinton Smith, a professor of biology at the University of the South. This is how the article starts off. Highly mutable, infinitely malleable, and all-powerful. This is often the underlying assumption for how spontaneous mutations fuel RNA virus adaptation. Though essential for adaptation, mutations with RNA virus genomes can exact significant fitness cost. Without the capacity to detect and repair mismatched or damaged nucleotides. Viral RNA genomes are prone to mutations introduced by mechanisms intrinsic and extrinsic to viral replication. However, large population size, complementation, cellular chaperones, and recombination can buffer viral populations against deleterious and lethal mutations. So what he is saying right off is that an RNA virus may be powerful, it may mutate often, and it may be adaptable. But what makes the virus more dangerous or less dangerous after a mutation is dependent on the host's body and external conditions, such as the size of the population. For example, a large population can make the virus less lethal than if it were to mutate among a small population. The article goes on to state, storage and transmission of genetic information depends upon the correct formation of hydrogen bonds between nucleobases. Mutations arise when mismatches are introduced during RNA virus replication or as a result of post-replicative base modification. Host RNA modifying enzymes and nitration or oxidation of nucleobases can alter hydrogen bonding and increase the probability of point mutations during subsequent rounds of replication. A mutation rate describes the rate, not frequency, at which spontaneous mutations arise during a single infection and reflects both cell and virus-dependent mechanisms. Because most mutations are likely lethal or deleterious or harmful. Natural selection and genetic drift significantly impact the observed frequency of mutations within a population. In other words, folks, an RNA virus, when it enters a host, the battle begins between it and your body. Your body naturally sees this infection as a threat and it goes to work, throwing all kinds of things at the virus. The virus now has to do everything in its power to keep replicating, and so it will often mutate during rounds of replication to adapt to whatever is interfering with its replication. This is again due to genetic diversity in the population, and so for every host that it infects, it has to adjust and adapt to that host as it infects and replicates in each cell. So you can end up with many phenotypes of the same virus in just one host. Now, here is something that is interesting about RNA virus errors, and it reads, RNA virus replication is error-prone due to the lack of proofreading activity, not because of an intrinsically lower fidelity polymerase. The one exception to this rule are nidoviruses within the families Coronaviridae, Roniviridae, and Mesoniviridae. Now, what does that mean? Okay, so let me take you to another article by Everett Clinton Smith and Mark R. Dennison, who is an MD, professor of pediatrics, professor of pathology, microbiology, and immunology, whose lab studies coronaviruses, or COVs, at the Vanderbilt University Medical Center in Nashville, Tennessee. Okay, and this was published in December of 2013, entitled Coronaviruses as DNA Wannabes, a new model for the regulation of RNA virus replication fidelity. It reads, coronaviruses contain the largest known RNA genomes. Coronaviruses, COVs, are positive-sense, single-stranded RNA viruses and contain the largest known RNA genomes, ranging from 27 to 32 kilobases in length, which is just the length of a nucleic acid chain. COVs are capable of trans-species movement as evidenced by the severe acute respiratory syndrome coronavirus, SARS-CoV, epidemic in 2002-2003. Additionally, the emergence of Middle East respiratory syndrome coronavirus, MERS-CoV, in 2012 demonstrates that COVs continue to cause severe and lethal human disease. Now, before I go any further, I have to tell you, researching and going through this stuff, I have to think. This is almost as bad as understanding the science at CERN. It is quite complex, but anyway, moving along. Let me tell you what proofreading means in this context. DNA polymerases are the enzymes that build DNA in cells, okay? During DNA replication or copying, most DNA polymerases can check their work or proofread with each base that they add. So the article goes on to read, RNA viruses rely primarily on low-fidelity replication by RNA-dependent RNA polymerases, RDRPs, to facilitate viral adaptation to complex host environments. Because of the lack of proofreading and repair functions, the average mutation rate of RNA viruses is estimated to be around 1 mutation per genome per round of replication. Much beyond this rate, RNA viruses risk crossing an error threshold, or the point at which there are too many deleterious mutations for the viral population to reproduce faithfully. The article then gets really technical and then summarizes with this. Coronaviruses encode a proofreading exoribonuclease that is responsible for genome expansion, increased robustness to mutations, and resistance to misincorporations during RNA synthesis, as well as being required for virulence. Experiments testing the proposed multi-subunit fidelity complex will yield exciting new insights into how COVs ignore the RNA virus playbook and instead seem to play by their own rules while dancing on the edge of genetic disaster. Now, if you didn't understand all of that, too bad. No, I'm just kidding. The reason I'm presenting this all to you is because it is not really being presented to you. I want to inspire you to look into this deeply on your own. I want to encourage self-education in the midst of miseducation. Plus, it is important to understand that there is nothing new under the sun. Coronaviruses are nothing new. This is a new outbreak because this is a new coronavirus that is already different than its parent form. See, viruses, especially ones like this, keep changing, just like the flu keeps changing. You get a vaccine for the flu this year, the virus changes, and you have to get another one next year, which is almost pointless because a virus can have thousands of mutations in just a single round of replication. Antivirals and nutrients are the key, not synthetic man-made crap. My goal here is for us all to become somewhat experts on this kind of stuff, because even after we are finished to some degree with this particular virus, there are thousands more out there just waiting to burn through the population. Now again, I want you all to think about this. The more deadly a virus is, the harder it is to spread. The less lethal it is, the easier it is to spread. Does that make any sense? It is due to population density and size. Something like Ebola is easier to contain because it doesn't silently kill you. It violently kills you. And you can clearly see who has it when it reaches a certain point. The coronavirus, however, can be mistaken by symptoms with other more common viruses like the flu. Is this a bioweapon? I don't know for sure. It is probably more of an accident that has been covered up. Because, accountability, blame it on the poor old bat. That way, no one person is accountable. Most people who are infected with this will survive it. Some will get it and recover from it without even knowing they ever had it. It is the diversity in our genetics and our nutrition. And slowing this thing down is really going to take people being responsible in public. We are all going to have to be OCD when it comes to cleanliness. Your new friend should be ethanol, alcohol, bleach, Lysol. Clean, clean, clean. Along with that, do not be suckered, folks. Let me tell you something. Actually, let me show you something. A friend of mine, Greg, who is a high school student, sent me something that was posted up at his school. And I will link his YouTube channel below in the description box. A very intelligent young man. Please go over and show him your support. He sent me this and it reads, Standard Infection Control Procedures for Coronavirus. Stay at home if you are sick. Okay. Cover your mouth and nose with a tissue when coughing or sneezing. In the absence of a tissue, cough or sneeze into your shirt sleeve or bent arm. Okay. Keep your hands clean. Wash your hands often with soap and water for at least 20 seconds. Actually, if you really want your hands clean, you need to do this for a much longer time, around 2 minutes each hand. You can actually go look up the scrub procedure for surgeons if you want to know the tricks of really cleaning your hands. Avoid touching your eyes, nose, or mouth with unwashed hands. Very, very important, and this could make all the difference between you getting infected and not. Avoid close contact with people who are sick. Yes, keep your distance, folks. Some things that many of you love to do, the nightclubs, the bars, the special events, you're going to have to make a decision about these things, especially if the virus is reported in your area. You can always party at home. Get the flu shot. At this time, there are no current vaccinations for coronaviruses. Why, you dirty, low-down, sneaky, greedy, disgusting, evil mother freakers. I can't believe they had the balls to print that in the same list. Stupid. This is going to hurt people. Anyway, disinfect your cell phone daily and refrain from handshaking. And this is a decent list aside from that one little flu shot ad they snuck in there. I mean, do you realize that people are selling hand sanitizer at markup prices, taking advantage of people's fear? It's nothing but rubbing alcohol and moisturizer. That's it. The bottom line is this. We have more to learn about this kind of stuff and this particular virus. And I will continue to bring as much information as I can on this as time goes on. But until then, I have a bunch more topics to cover, as you very well may know, and that will bring this update on the virus to a close. So until further information is released from me on this, folks, as always, stay awake, stay aware, stay safe, please. And hopefully, I'll talk to you all soon.